Hi everybody, episode 9, Defen, welcome. Hi VJ.
Hello Ray.
Hi, so yeah, Ray McDermott over here in Belgium, still hanging in there, waiting for the Brexit, still not happening yet, one of these days. And how's Holland hanging, VJ?
Holland is spectacular, beautiful and rainy as usual. And we have, I think today is some classic cars rally today coming all the way from Luxembourg here.
Oh.
So pretty old cars and stuff, I think.
That's amazing news, yeah. The only news I have is that I left my washing out overnight. Yeah, so that's how exciting my life is.
But that's why we're recording the podcast, to make it more exciting.
Exactly.
Yeah. Okay, so let's get on to the show. First of all, we'd like to bring everybody's attention to the amazing fact that Rich Hickey listens to this podcast.
Duh, duh, duh.
Oh, the horror.
Oh my God.
Rich, if you're listening, thanks for listening, I think. And we hope to have you on this show pretty soon. But anyway, that's the big news for last week for Defen.
Yeah, we're on our best behaviour tonight, so okay. So we do some things about the news and events then, VJ?
Yeah, a quick check on one of the upcoming events, I think in Tampere, I don't know, man. Yeah, somewhere in Finland. There is Closure.
I think Closure Tray, because it ends in Ray. I think that's good. Yeah.
You're just putting your name in there.
Okay. They put it in there, you know. I can't help it. But Closure Tray, Ray, Closure Tray.
We should stop butchering it. Okay, so there is an event, and we'll of course post the link on the show notes, obviously. And David Nolan and other great guys are coming there. So if you're around, you should visit Finland. And of course, we'll be there as long-time listeners of the show know that we'll be showing up in Euro Closure in October. We haven't still decided what we're going to do there. Apart from attending, we'll probably record some amazing discussions there, but we'll keep you posted. But let's get on to the main discussion. And as you guys know, we are trying to get different guests every other week, so you don't get bored listening to me and Ray blabbering in our village idiotry. So this time, we were very lucky to have not one, but two guests. And one is all the way from Australia, and the other one is right now in the US. So those guys are working on one of the... Probably, every language needs like a killer application. So I think Onyx is... Okay, I already announced what it is going to be.
Okay, the suspense is blown.
Exactly. Damn it. Anyway, anticlimactic.
We'll have to edit all that together now. But anyway, go on. Introduce them. The mystery guests.
The mystery guests who build Onyx. It's Michael and Lucas. Welcome to the show.
Hey.
Hi, guys. Thanks.
Hi, Michael.
Thanks, guys. Thanks for having us.
Hello, Michael, and hello, Lucas. First of all, thanks for joining the show. And I know it's practically 2 a.m. or 2:30 already in your time zone, Lucas.
Yeah, 2 a.m. in Singapore.
Oh, wow. Okay.
Are you having a party tonight, Lucas? Is that what it is? You just...
I'm the one that sacrifices for our distributed team.
This is the party.
This is the party, okay.
This is amazing because we have, I think we need somebody somewhere in the Pacific somewhere. Otherwise, we are now practically covering half of the globe, or maybe even more, in terms of the time zone spans. So Lucas all the way at 2 a.m. and here it is almost 8:30 p.m. And what's the time there in your time zone, Michael?
11:29 a.m.
Wow.
Right.
Okay. So real distributed computing and distributed podcast.
It's perfect for the subject matter, isn't it?
Exactly. So first of all, can you give us a quick intro about yourself? What you're working on and how did you get into Closure? Maybe we should start with Michael.
Sure. So I've been doing Closure for it's 2016, so I guess about 7 years now. I had.
Were you doing it before Rich?
I mean, Closure started in late 2005, so I suppose I picked it up about 4 years later. I wasn't quite part of the early bandwagon, but not too far after. But yeah, I was in college, kind of a hardcore Java person, and I just sort of hit my limit. I realized that the complexity budget runs out really, really quickly, and I started searching around for something else, and functional programming and Clojure and Haskell became particularly appealing, and the rest just kind of happened. Kind of left college, started looking for a job, started looking for a hard problem to work on more particularly. And databases, distributed computing, that sort of topic kind of caught fire with me. And it was really a matter of putting together what I knew were good design principles, learning Clojure the last couple of years, and then having a love of distributed computing, which is kind of now how I got to here.
Okay, fantastic. Before we switch to Lucas, what is your favorite editor, by the way?
My favorite editor, I am an Emacs person.
Yay!
It's so sad. It's so
awesome.
sad. It's so sad.
Yeah.
I'm not even going to go there.
Apologize.
All right, fine.
I'm sorry.
It's not a problem.
I've offended one of the hosts. I can't continue.
I mean, this is the same response every time somebody says, "What is your favorite editor?" I'm sorry, it is Emacs. It's like apologizing to every
It's like
entire
starting
world.
a family fight at dinner. I know I'm going to incite violence.
You know, we said you could swear on the show, Michael. Don't start now, all right? God damn it. Lucas, Lucas, please end your introduction with a better editor than that.
Well, I mean, I have to say I am pretty jealous of all the tooling that Emacs gets around Clojure. But yeah, I've been working in industry and analytics systems for oil and gas companies, and I picked up Clojure a few years back after working in C# for way too long. I wanted to move over to a functional language, and I was searching around for something to work on next. I'd done a bit of Haskell in the past, which I really liked, and I looked at Scala, and that kind of didn't really look very appealing to me, and Clojure looked just weird enough to be interesting. So I tried it out, and I've been loving it ever since.
Yeah, excellent. So you both mentioned that you were kind of into a bit of Haskell as well. So just maybe as an aside, what kind of like drew you more towards Clojure, the kind of untyped or dynamic type thing, rather than Haskell?
For me, it wasn't so much the type system. It was when I had a look at Clojure, it just seemed to have a lot more of the libraries were a bit more settled because you had you could use any Java library you wanted to, whereas Haskell at the time was a little bit more immature on the library front. And yeah, I mean, I really love Haskell still, but Clojure just really stuck with me.
Yeah, it was also I was going to say it was a pragmatic choice for me as well. Same thoughts.
Okay, so it was more about what you could do with it rather than whether the language was particularly beautiful or not. It was about, well, how can we practically do something with these things?
Exactly. And nowadays, I think it has an even better story because you get the benefit of ClojureScript as well, which is really a secret weapon.
But do you have a secret hankering to rewrite everything in Haskell?
From time to time. And then Mike gives me some sad faces.
Anyway, screw Haskell. We're on the Clojure podcast today. Yeah. Okay, great. Well, anyway, it's a nice backstory actually. So it's all about getting stuff done, which is great for what you guys are working on now, isn't it? Maybe it's worth giving a quick introduction to Onyx because, obviously, not obviously, you guys know a lot about it. That's fairly obvious. I know a little bit about it. VJ knows a bit about it as well. He's been doing some work with it recently. But obviously, it would be nice if you guys could give us a kind of high-level view of what Onyx is and what problems you're trying to solve with it.
Sure. So Onyx is a distributed high-performance computation framework aimed at elevating Clojure's strengths into the programming model. Essentially, it's a hybrid platform for doing stream and batch processing, which is kind of just a fancy way of saying that it's able to take a lot of data either in a continuous form or as a statically partitioned form and apply some transformations or aggregations to your data and very quickly compute answers to really relatively ad hoc questions. So when you break it down, Onyx is really a new programming model for how you can do distributed computation that emphasizes data structures and plain functions, and it's also a runtime to support that new programming model.
So it's big on data.
Right. It's markedly different from almost anything else out there that I've seen, in that the model with which you communicate to Onyx how your program is going to run is purely through data structures. And this is a vast departure from how almost all other platforms operate. They normally give you some sort of a code-centric API,
right,
which has a lot of advantages. But I really think that when you look at its design, the development level API really ought to be built on top of a data layer first, because it gives you much more flexibility.
So is the typical use case more like ETL, like extract, transform, load sort of use cases, or do you think there is some other like real-time analytics, these kind of things? They also scale well with Onyx.
I would say that real-time analytics is its strength, but it can absolutely be used for ETL type tasks as well. We don't try and dictate what it really should be used for, but yeah, real-time computation is definitely a strength of its. Given that its execution model is very streaming based, you can the batching is built on top of the streaming, but that leads to different strengths and weaknesses compared to other systems, but I think it does both quite well.
Look, it's funny because the way I look at that also, I try to explain it at work, is that you can always slow down streams, but you can't speed up batches. So you can kind of think of the streaming model as a unified kind of model for everything, and batch, you can just take elements of that stream and batch it together.
Right, I've heard it put as, batch is a special case of streaming.
Right.
Yeah.
Which is kind of what we have at the moment in many industries is a total separation, isn't it? And that was kind of the foundation of this Lambda architecture and all this kind of stuff, where you had the batch on one hand and the real time on the other hand. So this is a kind of unifying perspective as well. This tool that you're dealing with, the Onyx, is a kind of unifying the batch and the stream together, yeah?
Absolutely.
Okay, so the other thing you mentioned is that it's a distributed compute platform. So does that mean it's not suitable for like single computers? Or, I mean, I guess when you're doing development, you're on a single computer.
Sorry, I missed the question. Hangout's kind of garbled what you said.
All right. So I was saying, you mentioned that it was a distributed computing platform, Onyx, but how does it work on one machine? Can you do it on one machine, or is it... does it optimize for one machine as well if you've got a big machine with a lot of CPUs and a lot of memory, or is it only for the distributed computing world?
Yeah, it certainly works with a single machine, and we get that question a lot for designers who anticipate having much higher volumes in the future, but don't quite have that volume yet. So it'll work fine on a single machine. We don't specifically optimize it to work for a one node use case. But as you add cores and you tune it for the hardware that you're running on, Onyx will continue to take advantage of increasing number of cores, because everything that is meant to be fanned out is multi-threaded. So as you adjust the performance tuning, Onyx can continue to take advantage of additional capacity that you add. So we do see that a lot, because people end up wanting to build things that are more dynamic from the outset, and Onyx is really appealing because of its data structure-centric API. And hopefully that decision pays off. It's a risky one as to whether you want to go down the road of immediately building something in a distributed context that you think may grow, because you certainly do add complexity when you design like that. But it's an option, and if you think it's going to be a good play, then I think it's a good way to go.
I think that what we see is that people want to do some things, like you say, that are fairly small, and as things grow, then they want to have more like just more horizontal scaling. But sometimes they want to start off with a kind of vertical scale, just one big machine, just to do one particular task, then throw it away. But rather than having to dispose of, especially if you're on Amazon, to dispose of like 20 machines or provisioning 20 machines is sometimes more tricky than just provisioning one.
Right, and I think that's indicative of a deeper problem where you have people who are attracted to something like Onyx almost solely because of its flexibility. And that sort of seems to say that there's something about the programming model that a lot of these systems offer that is a paradigm mismatch between, why can't I switch between having one machine and having n machines, and why does it have to be such a drastic gap? People kind of want to have that layer of in between, the ability to shift up without having to incur a significant deployment cost or a complexity cost. And I think there's something more there that hopefully Onyx is seeming to tackle.
That's nice, yeah, because I think the key thing is here that you don't have to change the programming model between those two environments. I think that's the thing I see at the moment, is that in traditional kind of batch ETL, even streaming land message kind of processing stuff is fairly fairly small scale. And the move to things like Spark or Flink, it seems like a huge jump all of a sudden, or Storm or things like that. So maybe how would you compare it to those things, to those like standard big data systems?
So I would say it's closest to Flink and Storm, as opposed to Spark, in that it's built to be streaming first. Our model for programming on top of Onyx is significantly different to theirs, but overall the execution model is quite similar to Storm currently, in terms of the way that messaging is performed, the way that fault tolerance is implemented, and so on.
So what are the major, can you give us some insight into the design of Onyx? So what are the major components? Because if you see Flink and Spark and you see there are some technologies that they use that are fairly similar within them, for example, Zookeeper or Akka for concurrency. And obviously they're really, really tied to HDFS because that's where, they're going to get the data from. And also I think they support Yarn and this Hadoop ecosystem, so to speak, because that is the big data world. Can you give us some idea about what kind of libraries, or is it turtles all the way down with Clojure everywhere? Or what kind of components are there in Onyx, in design-wise?
I guess I'll take that one. Yeah, sorry. We use Zookeeper like the others. We found it works really well. It's reliable. So we use Zookeeper to basically act as a distributed data store for the job data. So anytime when you submit a job to your cluster, so you want to start a new job, you'll make an API call which will write that data to Zookeeper and then write a message to a log that all of the Onyx nodes are tracking. Which it uses to essentially decide, how many peers are on the network, what are they currently running on, so on and so on.
Okay, so you said there is something like a job, so maybe it would be a good idea to explain what job is in Onyx terminology.
Mike, do you want to take that one?
Yeah, sure. So an Onyx job is kind of akin to the most coarse unit of work that you can compute in Onyx. That's a kind of a collection of stages of work to be completed. So you would sort of imagine that you have data flowing in through particular slots of a multi-staged computation, and this job discretely breaks the stages down into first-class things called tasks, and the gap between tasks is presumed to be a network. So the latency of computing data coming into a task and exiting a task is going to be higher than it would be to transfer it over the network. And that's really why Onyx was built, to be able to fan out the various stages of a computation and have concurrency take over to increase the overall throughput.
So does it build something like, for example, in Spark, when I create a program, it is going to generate this DAG, the distributed acyclic graph or whatever they want to call, and each it has stages and each stage has tasks. So in Onyx, I see that you have this, as you were explaining, it is declarative. So I can put the whole program, or I don't know what is it, workflow.
Yeah. So what's fascinating about is that the workflow is the DAG. You actually declare what the tree is. So there's no impedance mismatch between what your program is and what we compiled to under the hood. We actually take the data structures you provide as is, and those become the program. The really interesting thing that's come up is that usually these platforms have some kind of an optimizer that you tuck under the covers, and you have your program. And under the hood, you're going to end up stitching some of these various phases together. You're going to perform fusion. At all points of the compilation cycle, you're going to start fusing things together that would be better performed at a single unit of time rather than spanning it out. We're actually able to move the optimizer around the stack. We've been able to elevate the optimizer up to the application level, where when you submit your workflow towards Onyx, indicating what the stages are, because it's plain Clojure, you can go ahead and just stitch those things together and have a much better understanding of how it's going to behave at runtime.
Yeah, that's like I was playing with Onyx, and obviously during my day job, I'm working with Spark a lot. And as you were explaining, every time I write a Spark program, I always need to go to the Spark UI to see the DAG and to see the stages and to see how Spark is optimizing, especially when I want to squeeze out the performance from the cluster. I need to submit a job and then see how Spark sees that one. But in the case of Onyx, it's really declarative. I can clearly see this is the step number 1, step number 2, step number 3. So that's very, very interesting in my opinion. And by the way, maybe this is a stupid question. So if I have a workflow, so obviously, if I understand correctly, you start with a workflow, and then each step, you can attach any Clojure functions and also plugins, right?
Exactly. Right.
Yeah. And in Spark, you have the RDD as the underlying data structure. Of course, they're moving to data sets and data frames, etc. But Onyx stays true to the Clojure, like it's just the maps, right, that are floating around.
Yep. I never did quite understand why there was a different abstraction for how you pass data around inside the cluster than how it exists outside the cluster. I understand that RDD has more implications beyond just what the structuring of the data looks like. There's actual optimizations and performance implications for how RDDs are set up. But really, they're maps. I mean, they are keys and values with their names and the names and their actual underlying values. So we keep actual persistent array maps being passed between the tasks all the time. And that ends up wiping away tons of complexity.
Yeah. And obviously, there is a plugin architecture in Onyx, so you can write your own plugins and plug into any of these workflows, right?
Certainly.
Or at any stage.
Lucas can actually talk a bit more about that, since he's been more of the architect of the plugins as of recently.
Right. So in Onyx, there are two main forms of plugins. You have input plugins, which are essentially to read from some kind of medium, and that would be the input nodes in your DAG, and they cover all of the fault tolerance aspects. So they need to deal with stuff like checkpointing and ensuring that the data is processed fully. And then you have output plugins, which are used to write to a medium. So say you want to write to a Kafka topic, that would be through an output plugin. And then we have a sort of third form of plugins, which uses lifecycles feature, which is kind of a way to hook in and change the behavior of your Onyx tasks. So using the lifecycles, you can do neat things like add metrics without actually having to for us to have to add hooks to Onyx, or let's say do something like inject Redis connections and you might want to output some data at various stages of the task lifecycle. So those can kind of give you a bit more flexibility as well. Yeah.
And so in the workflow, because this is a declarative thing, can the workflow be updated dynamically? As in, okay, I wrote a program, I defined a workflow, now I want to push changes to the workflow.
Not currently.
Yeah, we've explicitly not allowed that because it's always been my opinion that if I've seen other platforms start to implement this. I think you can get yourself into a world of trouble back in the space of being mutable. Because you'll have data that's in flight, and that's really the problematic scenario. What do you do with the data that's currently in flight? And at what point in time do you say that the workflow has transitioned from state A to state B? And you actually can't answer that question in a definitive way because it's concurrent. You'll have different pieces of data at different points of the stages. So those are questions I don't want to answer, and we don't have any intentions to do that. Even I think it's interesting to consider.
Well, I think you're right though, Michael. You used the perfect word there. It's immutable. What you want is you be able to reason about change, and that's the thing which I think is always a problem when you're upgrading systems or changing a version of something. If you can just mutate it on the fly, then you've got yourself. You might think you've won something, but actually you've lost more. I was just going to go. Sorry, go on, Michael. Yeah.
You see DevOps running in the complete opposite direction of that. We have immutable deployments now. There's something to be said about not letting things be too flexible in the wrong ways.
And it's not that there aren't solutions for this with Onyx. It would be our recommendation that if you wanted to actually change a job that's live, you would kill the job and then resubmit another job that takes over from where all of the checkpoints are at for your streaming job.
Sure.
There's no problem.
Yeah. I was just going to go back just to rewind a little bit about the APIs and the data and stuff. Something you mentioned there, Michael, which is why do other people do it differently? And it's kind of like interesting to me about the semantics of the data, because that's one of the things with Spark and all those other guys to me is that when you read their documentation, they kind of tell you, well, you think you're doing this, but actually you've got to consider that. And there are a whole bunch of their operations, their distributed operations. They have to kind of tell you under the covers, well, we're doing some wacky things here. So that their APIs kind of have data semantics underneath them, which they're trying to kind of hide, I think, in their APIs with this map and stuff, map and reduce things that are really distributed map and reduce, but they don't make it very clear to you. Is that something which I get the impression that Onyx is a bit more straightforward about?
Yeah, I think some of that is complexity that's inherent to the problem that you just can't get away from because of the physics of distributed computing. You're always going to have the ability to have your network partitioned and have things go wrong. You'll have the scenario where you're going to have data through reduce operation be asymmetrically sent to one node against the other and have problems. And I think that this is why you start to see, I don't necessarily think this is different with Onyx, which is why you see more people with performance problems with Onyx than you do with a database like Datomic. I wouldn't say the problems that Onyx solves are harder, it's just that the amount of work you need to do to make your program operate in a high performance setting is more difficult just because of how computers work and how they work when they're disjoint. So some of this complexity just probably won't go away because it's not a beginner's tool, it's not a beginner's domain. So I hope Onyx does address some of that, but in another sense, it's probably just not going to get easier because of the domain, I would say.
Because cap theorem basically brings you problems, in other words.
More or less, yeah.
Yeah.
The thing I always point to in this case is just use good metrics, monitor your systems. That'll help you more than anything else could.
Okay, so that's the kind of thing that I guess people should be doing by default anyway with any system, whether it's distributed or not. But I guess it's more important with a distributed system because there's a lot more moving parts.
Absolutely.
So if I understand correctly, I'm trying to form some sort of a mental model of how Onyx is working. By the way, why Onyx? I mean, how did you pick this name, by the way?
I don't remember, to be honest. It's been about 3 years now. I wish.
Now you can come up with a magical story.
We're trying to come up with a name for our upcoming product, and we've been at it for a good 3 months now. Naming is probably the hardest thing that you can do because all the good names are taken. You want a short name, you want a name that has a domain available. It's just it's harder than actually building the program.
That's true. Maybe you can say, hey, I was sleeping and then one day Rich Hipke came into my dream and he told me distributed computing is hard. I can't do anything. And they're like, okay, I should do something.
Shout out to Rich. We're dreaming about you.
Anyway, so to get back to the discussion, so the in Spark, I'm sorry if I'm bringing up Spark because that is something that I'm really familiar with,
sure.
Or at least a bit more familiar with, not really. In that you see that the execution model is essentially there is a driver and there is a lot of executors, and the driver is essentially driving the program, and the driver is also responsible for retries, for example, if a node goes down or it doesn't finish on time. So how is this model in Onyx? Is it truly like masterless, or is it like a supervisor plus supervisees, I think? How does it work in Onyx?
Mike, do you want to take this question on the log? Yeah.
So when Onyx was designed from the outset, I did design it with a leader and followers architecture, similar to Spark, where you not necessarily have a driver, but you do have a centralized coordinator kind of pulling the strings on all the puppets and making things work. And I suppose after about a year after I launched it, I realized that there was some room to do something else interesting here, and I started to have thoughts about, well, what would this look like if it were actually masterless in some sense? Not quite peer-to-peer, because that's really a fully decentralized system, but what would masterless look like if you took the centralized coordinator out of the system? So no one was really using Onyx at the time, so I had plenty of room to play around, change the API, change everything. And I had been reading a lot of papers on databases the last couple of years. I had a lot of good things in my head about what else could you do. And one of the themes that stuck with me was the notion of a centralized log. Logs are an incredibly flexible architectural kind of thing that you can use. And it kind of dawned on me that you could have a system where you don't have a centralized coordinator because you have a durable centralized log, and you have all of your worker processes, which we call peers, replicating each entry from the log and taking the brain that used to be in the centralized coordinator and then moving them into their own process. So really, we just took which was once a centralized process, and then we moved that exact same process into the worker. We replicated it, and that ended up doing really wonderful things. It didn't solve all the problems that we had. It made new problems, but it's you trade one set of problems off for a different set of problems. But the trade-offs are interesting because now you have a linearized sequence of actions that occur throughout your cluster in a durable manner. Again, this is unique to Onyx, and I don't know of any other platform that has this. But it has allowed us to do some really interesting things where you don't have a driver program anymore, which is pretty cool.
Okay, that's pretty nice. But from the semantics, sorry, Lucas, were you saying
I was
something?
just going to say, Clojure test check has been fantastic when testing, building this masterless log-based architecture. Because getting all of the scheduling and peer join, peer leaving issues right was quite difficult.
Okay.
So you've got a lot of race conditions going on there, basically. Or potential for race conditions.
Yeah, potential for interleaving log histories that could end up in, race conditions, cases where the peer's view of the system is wrong, that kind of stuff. And test check was just fantastic for that.
Maybe I need to ask you that question a different way than Lucas or Michael. It's like, okay, so if you have this log in the middle, that's great for kind of like work done, which is like the Kafka approach where you log everything that you've done in Kafka or in a database log or whatever. But are you trying to say that you want to use the log as a kind of way of spreading work out? And then if that's the case, how do each of the peers decide that they're the ones to do this work?
Right, so it's mostly used to decide on the peers' view of the system, in that these peers are currently running the system, which peers should be scheduled on different jobs, this sort of thing, rather than actually using it to communicate the work.
Okay. So it's about scheduling rather than breaking the work up.
Yeah, it's about getting rid of the coordinator.
Right. Okay.
So what kind of semantics does Onyx have? Is it like, for example, only once guarantees, or is it going to be something like, okay, it can retry multiple times?
Yeah, Onyx offers at least once guarantees and quote unquote exactly once guarantees. The other one being at most once, which we just kind of haven't bothered to do because I suppose I've never had a use case for it, and it's not particularly hard to implement, but no one's ever asked for it, and I've never needed it, so it just never got done. But at least once, meaning that if there's a failure, Onyx will continue to try until it processes your data, no matter what. And exactly once, meaning aggregations like a rolling summation, where you're not going to take integers as they come by and then add them up. And if you have a retry, it's not going to add them again. It's going to come up with the appropriate sum, regardless of how many times it's retried because of a failure.
Okay. By the way, is there any plan or maybe some sort of an ideas behind? Because one of the reasons why we pick Spark at the place where I'm working for a bank. So we are looking for machine learning related things a lot. Like iterative algorithms, all sorts of, I'm working in fraud detection algorithms. Do you guys have any plans or design ideas on how these things can be implemented on top of Onyx?
Right, so, absolutely. It's actually a little bit tricky to do right in the current messaging model and the current way that Onyx works, which is closest to the way that Storm works. We're currently working on implementing asynchronous barrier snapshotting, which is the scheme that Flink uses. After that's done, things like iterative computation will be significantly easier. So we'd like to see a lot of that kind of work after we get the ABS work done.
Okay. Yeah, basically the iterative computing is the core of all these algorithms, right? I mean, distributing the work and then calculating it and combining it again. But that'll be very interesting to have in the closure world, I would say, having a proper machine learning algorithms.
Absolutely.
Okay, let's go to. Okay, so building an Onyx app. So what? Just consider me like a noob. Obviously, I'm a noob for Onyx. How would I build an Onyx app? So it's basically embeddable, or is it? I just start with small Lineagen plugin or whatever, or just keep using Onyx as a library.
I think this is one of the challenges of Onyx, even though it's actually a strength in the end, is that it's so malleable and flexible that it's kind of like, well, where do I start? We have an application template. We have a workshop that you can follow. We have tons and tons of documentation. Off of our website, we have kind of first steps where you would start. And I'd say the Lineagen application template is probably the best place. Or if you're going to go sit down and write a serious application that's supposed to do something, you can go ahead and spin up a new one, and that should put you in a good state. The difficulty being that if you're going to expose Clojure to such a great extent, you're decidedly moving away from framework. Framework is really great for getting people started quickly and then forcing them into doing things a particular way. But as you move far away from that, you get more flexibility and more strengths to tap into the core language, but you also make it more tricky for the beginner. So I guess it's kind of our Achilles heel, and one which I'm totally fine having because, again, we didn't design this for beginners. This is really a tool for people who are doing serious production work. But some combination of starting with the application template and then having a thorough review of the documentation and learning about what it does first before diving in too deep would be helpful.
Yeah, I think when I started looking into the docs and obviously the Learn Onyx project on GitHub. That was very helpful because I think you have this nice test-driven workflow that I need to look into the tests and then basically learn the concepts one by one. So that was very useful for me. So I think if people who are interested in learning Onyx, I think that would be a very nice place to start, I would say.
We've done that workshop live a couple of times, and it's been always a really fun thing to do. So if you know Onyx particularly well and you want to teach other people, I would recommend maybe doing a meetup and just having people walk through it and ask you questions, because it's so self-guided that it ends up being easy for people to teach themselves while occasionally asking questions.
Yeah, actually in October, I'm going to do a Onyx workshop in Amsterdam, Clojure meetup.
Cool.
So my plan is to use that one. And obviously, I'm going to bother you guys with a lot of questions working on this one on Slack, though.
Perfect.
Yeah.
I might come across for that, Vijay. Sounds good. Yeah.
Sure. The idea is to do it in September, but I'm going to Flink Forward event. So that's in Berlin. So I couldn't do it this month, but I'm going to do it the next month in October. So it'll be awesome. If you can join, then you can give a field report for Defen.
But so just going back to your sort of thing about building the Onyx apps, though, Mike. Are you saying that essentially you're writing a Clojure program? So you use the kind of the pattern of Onyx, the mapping and stuff like that, but most of the functions that people write will be Clojure functions that essentially operate on the data?
Almost entirely, yeah.
Because that's a huge win, isn't it? I mean, if people are basically bringing their own workflow, then that's a tremendous gift to the developers, I think, because they can bring in their own libraries, their own functions. They don't have to rely upon. Well, they can rely on the ecosystem of Clojure, but they don't have to rely on some special ecosystem.
We hear that a lot because people will start to become interested in Onyx and see that you primarily use plain Clojure functions and data. And I think I have 90% of the work done because I wrote a single JVM app, or I wrote something in a different kind of framework that allowed me to still use Clojure. And so all I need to do is figure out the plumbing and the wiring to stick it all together, because none of that has to change. And I think that that's a big win for engineering costs.
Excellent, yeah.
By the way, the whole distributed state management with log, maybe this is completely unrelated, but I'm just going to throw it in. Did you guys take a look at About at some point? That was supposed to be distributed Atom implementation.
About. Yeah, I think I have seen that. There's a couple I think About has primarily been abandoned, unfortunately, because it can't support the semantics of some operations, because Zookeeper doesn't support continuous watch triggers, which is when a value changes on a Z node, it will continuously update any subscribers, which is what Clojure does. But Zookeeper doesn't allow that, so you can't really match the semantics.
Okay, so that's not really I remember looking at it, I think even years ago, several years ago, I think. That was supposed to be like a distributed Atom, but managed by Zookeeper, and then state you can save it to, I think there were plugins for MongoDB at that time. But anyway, as you're pointing out, I think it's essentially an abandoned project right now.
But aren't we talking about here though about immutable data anyway? So the distributed Atom bit, is that really a thing?
Actually, our state management, Lucas wrote almost the entire thing. You can talk about it. It's intentionally designed to be relatively immutable.
Yeah, so the way we built windowing and state management feature is that you're essentially building a state machine that's based, a replicated state machine that your data is being pushed through. And that's all journaled to Bookkeeper, which is a distributed log. And this provides nice fault tolerance semantics. If you have a node that crashes, another node will pick it up, replay the state machine log, which will get you back into the state the windows were in and your aggregations are in, and then continue going.
Excellent. Okay.
So now one of the challenges for us, at least, especially getting into distributed computing, is the deployment stuff. So if you see other I think deployment has been one of the biggest painful parts in Storm, as far as I remember. And obviously the other stacks, they have their own way of running on top of existing ecosystems like Yarn or Mesos. So how a developer or a DevOps guy, what is the recommended way of deploying Onyx?
So the tricky part with deploying Onyx, which I'd used a lot of the tooling that existed before I built it, and I was really frustrated because the primary way of doing this was building against this framework, creating an Uber jar, and then submitting it to some master process. And while that actually does the orchestration pretty well for the transportation of your program to the various nodes in your cluster, it makes so many assumptions about how the way the things ought to work that you lose any benefit, I think, that you got in the first place. So Onyx is a decidedly a la carte deployment process where you create an Uber jar for your worker processes, and you actually invoke a function to start up all of its thread listeners, and then you block, and so it keeps it online as a persistent daemon. So virtually all of the infrastructure related to doing deployment is kept outside of Onyx itself, which means that you can run it in a container, you can run it on Kubernetes, you can run it on Mesos. It just doesn't work that way out of the box. So you have to do a little bit extra footwork to set it up the way you want it. Now, my hypothesis is that you were going to have to do that work anyway, regardless of if we shipped something that was kind of prepackaged, and you would kind of have to backtrack and then set things up the way you wanted anyway. So it may be one pain point for Onyx, but I think it's one of those things that pays more down the road as you use it continuously.
Okay. Yeah, I mean, I can tell from my experience that the way that we deploy Spark applications is basically driven by Ansible, and we have some sort of an entry node to the cluster, and then we jump to it, and then from there we do the Spark submit. But we use Yarn as a resource negotiator. But Onyx doesn't require any resource negotiation frameworks, right?
None. Only if you want to have it. You can go ahead and integrate it at that point.
Okay.
I think we could do a bit better of a job of adding some extra tutorials for Mesos and Kubernetes and co.
Yeah, that'll be very useful, because whenever I start with this kind of experimenting with these kind of things, I just boot up a cluster with 6 or 7 machines, and then I go through the entire life cycle. Build a program, deploy it, and see how the framework is supporting me in terms of deployment. What kind of access do I need to give to the DevOps teams? Because these are all big problems, especially if you want to if you want to get into this enterprisey mode of deploying applications.
Agreed.
So there it is like super painful situation, because I ask, okay, can I get the shell access? Then everybody will be like, no way. So how do I deploy this thing? Because I need to type in spark submit.sh everywhere. So that is one of the bane of my existence right now. Anyway, okay, let's get into the next interesting thing. So what kind of tooling and available around Onyx? I know Onyx dashboard is one of the projects that you guys are working on. Can you give us some insights on what tooling is available right now for Onyx, and what are your plans?
Sure. So Onyx dashboard is a great one. It's primarily used at the moment to give you a view of what's going on in your cluster, what nodes are currently up, what's the overall state of your cluster, and give you some visibility into what jobs are running, what is the job, what catalog is contained in the job, what does the DAG graph look like, and so on. And we generally recommend that when new users are getting up and running with Onyx, that they have a look at what's going on in the dashboard, because it gives them a lot better of an idea about what's actually going on internally.
Yeah. So is this a separate application that needs to be run, or is it inbuilt into Onyx itself?
It is a separate application. We are also going to be releasing a sort of daemon that you can start up with your Onyx peers, which will give you visibility into what their view of the of the system is. So you can sort of see, okay, what nodes do they think are online? What job are they actually running? So that could give you quite a bit of the information that the dashboard would give you currently without some of the overhead.
Okay, so what is the kind of communication that we need between Onyx dashboard and the peers? I mean, where is the information coming from?
Because of the way that a cluster is designed, using the log-orientated architecture, the dashboard only really needs to look at Zookeeper and read the job data and play back the Zookeeper or play back the log that Onyx uses, and then as a result, it will actually know what the current state of the cluster is.
Right. Okay. So it's nice and distributed, and doesn't have to reach out to each of the nodes in turn and query them and have all this kind of crosstalk.
Right. Not unless they want to do some sort of health check on the nodes. No.
What's fascinating is that it can almost function as a read-only peer in the cluster, where it's listening as if it were exactly a node in the cluster, except it's not doing anything. So it's just passively listening to all the activity in a durable context. So the design allows for really good extensibility, and Onyx Dashboard is just one of the examples where we tap into the log in order to almost participate in a passive manner.
Okay, so actually the log provides you with a kind of database to snapshot and to interrogate and to analyze the current flow of work in the system.
Exactly.
Absolutely. Yeah. It's shown to itself to be very handy as well when we're debugging issues with clusters, because we can just take a dump of the log and then play it back step by step and look at each node's view of the cluster.
Yeah, it sounds like a huge win actually from a design perspective as well, because you don't take any performance hit for monitoring.
Somewhat true, although we do actually need to have node level monitoring on what work each node is actually doing at any given time. So the log doesn't actually give you any visibility on how much data is passing through the system. What's the throughput, latency, this sort of stuff.
So how do you collect that bit of information then on top of the worker log?
So we have another plugin, which is Onyx Metrics, which provides outputs for a bunch of different metric systems. So if you're using Riemann or New Relic or Datadog, you just hook it up, have it connect to the right place, and it will emit metrics for all of your jobs.
Okay, excellent. Yeah, so you can use the same operational tooling that you're using now, just through one of these plugins.
That's right.
So the performance-wise, sorry, Ray.
I was just saying it was sweet. That's all.
No. Sweet. So we're talking about performance, right? So how because nowadays there is this huge bleep measuring contest between all of these frameworks. Hey, I'm faster than this thing. We can do real-time analytics, and you can't do. So this kind of crap going on a lot between all these frameworks these days, right? I mean, Spark keeps on saying we are the fastest, and then Flink says no, we can do this stuff better, and these kind of things. But when I see Spark API and all that stuff, because that is completely different model, as you were pointing out before, that RDD is the central idea behind Spark, and then of course data frames and datasets, and the programs themselves are not real Scala programs but Spark programs. There is a slight difference between writing a Scala program and a Spark program, because there are, RDDs are not flat mappable, blah blah blah, whatever. Now, how do you see the performance characteristics of Onyx? Because it's really like just using plain Clojure, right?
Right. I would probably start by saying a lot of these benchmarks, as you're saying, are borderline infuriating because they're so context dependent. As someone who's we've designed these things and we understand how much complexity is involved and how specific these tests have to be. So having a full comparison across the board, unless it's for your particular application, you should really take it with a grain of salt and instead understand how the design works under the hood. You'll get miles more of productivity out of that instead of looking at a graph and saying, oh, this bar's higher. So
maybe it's about fundamentals, Michael. It's about what kind of things are essential barriers or enablers to performance. Maybe that's a clearer cut kind of discussion.
Yeah. So while the API is primarily Clojure and its implementation is Clojure all the way down, a lot of the designs across these various architectures and products are they're not the same, but the ideas are similar, because you're trying to make progress on a particular set of data. You're trying to do it in a fault-tolerant way. You're trying to do it in a way that requires as little messaging as possible, as little checkpointing as possible. And so really, how do you do the least amount of work and have the least amount of overhead while not disrupting your application's progress? And so we have a fairly good performance profile right now using Storm's record at a time model, which is essentially a way to track a record's lineage throughout the system in a very performant manner. But we're switching to what Lucas said, ABS, asynchronous bearer snapshotting, in an effort to reduce the number of acknowledgement messages and number of checkpoints that you have to do. And so I'm hoping that our performance is going to get really, really good after we do this, because we're able to do it in a way that no one else has right now. ABS is primarily implemented through a pull-based architecture, and we've come up with a way to do it through a push-based architecture, which usually push-based will be faster than pull-based. So this is another case where you look at how things actually work, and their mechanics are more important than any particular benchmark.
But maybe it's if you can run the benchmarks, Michael, you can stop the benchmarks being infuriating to you and make them infuriating to everybody else.
Yeah.
Yeah, I mean, I suppose we could always publish something and say we're fastest because these are arbitrary. I'll play the game.
It's just like,
use case for you,
Yeah.
Well, it's just like our podcast being the world's #1 R-rated vegetarian Clojure podcast. So in that specific area, we are the #1.
Yeah. At the end of the day, you only need so much performance, and if you run the application and it's good enough for you, then, I mean, who cares what's the absolute optimal conditions that this thing can run under?
One thing we've seen quite a lot of is after a decent amount of optimization work, we tend to find most users' performance problems are easily dominated by the work they're actually doing themselves. So what are their Clojure functions doing in between the tasks? Possibly sometimes there are cases where they need to optimize by collapsing down tasks to, eliminate communication between peers. But, that kind of thing is more about thinking about how your tool is working, not so much what Onyx's internal performance is like.
I guess what most of the things that people compare performance with is, I think there's two aspects to using any tool, isn't it? One aspect is, you want to make sure that the workflow and the style of programming and the kind of tooling is up to scratch or meets your cultural expectations. But then you want to make sure that also, from a management and cost perspective, you're not buying into something which is inherently more expensive than something which might be slightly less comfortable, but is going to cost you 50% less on your Amazon bills or something. So I think that's what drives people. So I guess that's what drives a lot of these benchmarks is, in the end, people have to rent their machines, so they want to make sure they're not going to be overpaying. And as long as you're in the same kind of ballpark in terms of rental costs for compute, then people will focus more on the more hygienic aspects of how you work with the APIs, how you work with the tooling and that kind of stuff.
I think this is one of the drivers of why people are able to build businesses around these products despite them being open source, which is what we're doing now. Onyx is entirely open source, and yet we're able to construct a business. And I think it's primarily due to the fact that if you can shadow a lot of the problems of actually hosting and running these things and come up with a cost model that's meter-based and usage-based rather than machine time, you can build a viable business model because people are willing to go ahead and focus more on the things that matter from an engineering perspective, like API clarity.
Yeah, I hope so, because that's a thing which I think in the end should drive progress. rather than
Agreed.
because to kind of look back at the technology wars, and people like, I dread to think, that Oracle won the database war because of its performance, so it would be horrible if we repeated that mistake,
Yeah.
Sorry, VJ, I know you're a fan, VJ, sorry.
Me? No. Well, I got paid by Oracle at some point, so I have some
You're tainted.
history.
Sorry, that's just a bit of trolling, bit of in-house trolling there.
I have been to the land of Mordor and came back. Anyway, so because there are lots of other technologies in this space, right? I know. So Lucas, you were explaining the plugin architecture. So how well does Onyx play with other technologies? So what kind of tools are available right now? What kind of plugins are available?
Right, so we do a pretty good job of supporting a lot of the main ones that people ask us for. So, I mean, our first couple plugins were Kafka and Atomic.
Yep.
They would probably be our most frequently used plugins still to this day. Kafka, because it's a really great fit for the streaming model that Onyx uses, and it's being used a lot more in industry, I would say. And Atomic, because obviously a lot of Clojure users used Atomic, and one thing that's actually been a really great fit with Onyx is using the input plugin that reads the Datomic transaction log, because that allows people to basically replay what was going on in Datomic or react to new events that are happening or being written to Datomic. As far as the other plugins, we have an SQL plugin, Redis plugin, S3 plugin,
Yep.
Amazon SQS plugin, and a few others I'm probably forgetting right now. But we continue to add them as we can and as we get time or as people contribute them.
Those are plugins, Lucas. Are they like based on a Clojure protocol, or so is it relatively? How do you implement them? If I wanted to do one for I don't know,
MongoDB.
pardon me.
MongoDB, the Snapchat of the databases.
No, I'm not going to do for MongoDB. No, but maybe I would do it for
Rethink.
Oracle.
I was going to say DynamoDB or something.
Sure.
You would do
sure.
one for Oracle VJ. You could do that.
Which there has been one DynamoDB one, but it's quite a bit older, I think. So in the last few versions, we switched over to a protocol based implementation of the plugins. So as long as you implement either the input protocol or the output protocol, usually pretty much good.
Okay. So how much work is that? I mean, like how many things do you have to implement to satisfy the protocol? Do you end up hooking to a lot of your log things, or is it, under the covers, or is it pretty much, if you can essentially tap into the input, like say, okay, I know what the API for DynamoDB is, for example, so I can find out, okay, how I make a connection to it and then how I read the data. Am I pretty much good at that point in terms of your plugin, or are there more specific things to do?
So for the input plugins, you do need to do a lot of the work yourself. So input plugins are actually significantly harder to write than the output plugins. They're not too hard, but they're harder. Now this is because you have to implement a lot of the stuff like checkpointing where you're up to in the stream.
Right, okay.
And also dealing with the retry semantics. Basically, you're implementing the fault tolerance aspects yourself. This will be getting a lot easier in the next version of Onyx, though. Because
I'll wait then. I'll wait till the next one.
I'll try not to avoid
It's a recommendation.
We were just
You just want to do the easy
yeah,
work.
exactly.
we were just
Do the heavy
talking
lifting,
about-
Lucas. Come on.
We were just talking about not Osborning ourselves. and preventing people from writing plugins. Output plugins won't be changing much, though. Those are actually quite easy because you don't have to deal with the fault tolerance aspects. You just have to take a batch that's given to you and write it out somewhere.
So the plugins are essentially, if I understand correctly, that you implement a protocol and then there is a function that gets the segments, right?
Yep.
Okay. So a segment is essentially a map of information or a closure map.
Yeah, they're essentially akin to a record in other systems.
Yeah.
So maybe an interesting one would be, I mean, not Mongo, but maybe it's Rethink DB. Are you guys seeing much of that recently?
Yeah.
Yep, there is a plugin out there.
No, that's what I was going to say. I was trying to recall whether someone wrote one. I was pretty sure that actually happened at some point. Nothing further to add.
Yeah, I was going to say we could just list maybe it's Cockroach DB. List the most kind of gruesome names of all databases.
That one actually looks really interesting.
Yeah, it's like a survivable database that doesn't die apparently.
Yeah, that's the thing. That's why I call it Cockroach, isn't it? It's highly resilient.
Yeah. I love their motivation though. So basically we need to write Cockroach DB, data into Cockroach DB, and then send it into the space, and that's it.
We dropped a nuclear bomb on it, and then we looked, and it was still there.
Exactly. And by the time it reaches Alpha Centauri and the new habitable planet, they should probably know how to write Onyx plugins.
I was going to talk about SpaceX there, but maybe we shouldn't do that this week.
Too soon, man.
Wow. Okay. Well, talking of testing.
No, maybe we should talk about SpaceX. Then we'll see an angry tweet from Elon Musk, and then we can invite him onto the podcast.
Yes. Yeah, we can.
That'll be awesome. But anyway, so testing, yes. Okay. Sorry. So Ray, you were taking the discussion towards testing now, right? So how do you guys test Onyx? Because I saw some tweets by you guys about Jepsen and how it helped you. So can you give us some insight into how you use Jepsen? Jepsen. Yeah.
Maybe you should give a quick intro to Jepsen actually, because it's I don't think everyone knows it. Probably quite a lot of people do, but maybe it's Michael or Lucas. Do you want to give a quick background on Jepsen first?
Yeah, go ahead, Lucas. This one part's your baby.
So Jepsen is a library written by Kyle Kingsbury, which he built to support his Call Me Maybe series, which is a really interesting series of blog posts which describe how he's tested various distributed systems, primarily databases.
Yeah, excellent series of videos, I think, and blog posts.
Yeah, and I think he's really done a lot of good work in changing expectations as well about the level of testing and the ways that different products are tested. Because I think there's been a lot of cases where products are put out into the wild and used in production before they're really ready. And I think he's just really raised the bar for what's expected.
what he did especially was he called people out where they were saying they were safe in a distributed split brain world. They were resistant to it. They were okay. And in fact, his tests proved that they weren't. And I think he was calling bullshit on a lot of people, basically. And I think it's fair to say that.
Yeah, and even in cases where the products don't support it, these things should be documented so that practitioners can make the right choices about the products that they're using.
Yeah, because I think a lot of this CAP stuff is all about you making the choice over availability or consistency or whatever.
Right, and so as at the time 2-member team, we felt that it was important for sake of both professional pride and also trying to prove that our system Onyx is production ready. So we put it through. We built some Jepsen tests with it. So we used his library to build some tests around, getting jobs running on a 5-node system and then partitioning them from each other. And then checking the results that came out of the job and making sure that no data was missing, or in the case of exactly once aggregation, that no value was counted twice, for example. And, even though we had a lot of property tests that ensured that some of the testing space was covered, we found that Jepsen picked up a lot of issues that weren't covered by, testing in a pure way. We found that there were a lot of issues around connection handling, for example, or concurrency issues that it picked up. And yeah, we feel that we couldn't have picked up these issues without using something like Jepsen.
Fantastic, yeah. So did you talk to Kyle about it, or has he been involved a bit, or was it just you using his tools and kudos to him?
We have talked to him a little. We paid for a few hours of his time, but he wasn't super involved in it, so we only have ourselves to blame for the methodological issues in whatever our testing did. But yeah, he was super helpful, and highly recommend that people go out there and hire him.
So do you get a picture of Carly Rae Jepsen now on your website to prove that you're passed the test?
Well, what he said was that there is no proving. You can only prove that it doesn't work.
It's an honor system.
After having been through the whole process of testing it in various ways, including Jepsen, if you're writing a distributed system, I can't imagine that you could have real confidence in it without doing, if not Jepsen, some kind of simulation testing, because the number of things that we've seen go wrong is just unanticipated. I'm not saying our work was bad. We put as much effort into our work as we possibly could. It's just inhuman to think you will catch all the things, and some of the things will be really bad and embarrassing. So if you're an aspiring distributed systems designer, yeah, really go out and try to beat this stuff up with the best tools you can.
Yeah, we practice Jepsen-driven development now.
Yeah.
Well, I had to do some data cleanup these days. I think we have around 600 gigabytes per day, and I wrote a Spark program, and obviously I'm a noob and the village idiot. So it's basically cleaning up huge amount of chunks of JSON data, or transforming it into something. So initially I thought, okay, I'm going to look for this data and I don't want to construct a lot of objects, so I didn't use any string builder or anything. I'm just going to do string index of substring, so it's going to be really memory efficient. And in the case of replacing some data in the string, I used replace all instead of replace, and I ran it for 2 days or something, and everything was going hunky-dory, so I didn't check the results. And then later I figured out it was filled with exceptions, because the replace all treats the string as regular expression and replace treats the shit as normal strings.
I didn't know
So
that.
I used replace all. Yeah, that was fascinatingly painful thing to realize after processing, I think around, 1,000 gigabytes of data.
Yeah.
I'm like, oh, fuck. Oh, yeah, there you go. We have our first fuck. Yeah.
Cheers.
I remember this YouTube video, by the way. There was somebody recording developers, and everybody was on headphones, and all you can hear is shit, fuck. Anyway,
It's like listening to my kids play video games.
Exactly. So this is, yeah. So as you can see, the kind of errors are at a distributed scale, and it is like big data scale. Like, holy crap. I mean, it has been running for 3 days, and my data, when I looked into the data to test what is happening, I put in try catch all errors and then write this line, and the whole file is filled with those lines.
Yeah, what's clear is that as you get up towards that level, you need a different set of engineering tools to be able to work efficiently.
Yeah.
And that's the primary challenge.
Exactly. And this is after, tweaking all sorts of knobs on Spark, because to make it run faster, to make it all sorts of stuff, and spending a lot of brain cycles. So this is I mean, I'm really amazed with all the work you guys are doing. It's it's very, very hard problem. I can imagine, even for an idiot like me who is just using the tools,
It's a labor
I
of
can
love,
imagine
I
building
suppose.
it. Yeah, but it's really fantastic, by the way.
I was just going back to your point there, Vijay. One quickie is one of the things that I liked about Clojure at the beginning actually was the data set, the data structure things, where Rich was very clear about the big O notations around operations on data structures. And I think that's the kind of thing, isn't it, that we can't necessarily get for these distributed data structures. But if we could have something similar to that, then
I think for big data, I think there should be big F notation.
Right. Okay.
So for normal computation, this is going to be big O
or log F,
and this is going to be oh fuck notation. This is crazy
aiming
stuff.
for log F rather than linear F.
Anyway, so obviously, so you guys are busy scaling up Onyx as a company. So can you guys give us some idea about who is using Onyx and how? Some use cases or maybe some name dropping.
We're seeing a lot of. Oh, go ahead. Sorry.
Oh no, you go ahead.
All right, so polite. We're starting to see a lot. Yeah,
Can someone go ahead?
Yeah.
There is some sort of problem with the leader election here.
Consensus between two processes is already difficult. Hold on, we're gonna run Paxos very quickly. Just give it. We're starting to see a lot more people move into real-time analytics. That's kind of been a sweet spot where latency needs to be relatively low. Streaming-oriented problems. We've even seen a little bit of action in the financial industry. No name dropping there, but we're starting to see Onyx be used to deal with money, and that's kind of a point of pride. I mean, to see things get stable enough where people are willing to do some kind of real time, financial stuff is pretty great. So it's certainly proven to be more stable. The number of use cases that I know about in production is probably somewhere in maybe 10 companies range, but we have people kind of drop in the channel every now and again and say, well, we got this Onyx system. And I say, I had no idea. So wow, you never even had any questions for us. That's fantastic. So really, who knows how many people are using it? I'd project maybe somewhere in the 15 to 20 companies range are in production.
No, I know for sure that Cognition uses Onyx, right? I mean, Robert Stutterford, who was here for talking about Datomic, he wrote a wonderful blog post.
Yeah, you should put that in the show notes. It's a great post.
Okay. So now the next question. First of all, not first of all, but probably last of all now. A very big congratulations on getting the funding for Onyx. So your company Distributed Masonry. Now that shows that there is a lot of trust, even from the external people, I hope, making sure that Onyx has bright future. So what are the future plans for Onyx?
Thanks. First of all, we were able to raise an investment round of $500,000 to be able to push us through another year and a half. And really, we're looking to sort of shift towards being strictly a consultancy into a hybrid of a consultancy and a product development company. Really, the goal of Onyx from the outset was to lower engineering costs for building these kinds of systems. It's clearly a very expensive endeavor. It takes a lot of time. And so building Onyx was an exercise to see how low we could make those costs. And what it came down to was that the costs still aren't low enough for us to find that there has been an acceptable change. It's gotten better, and I think primarily Onyx has done a good job of increasing confidence as you're building these systems because it's more clear about what you're building, if it's correct, how it behaves. And so confidence has increased, but actual time from moving from scratch into an Onyx production system, I don't think is significantly better than in any other tools yet, just as a field study from what I've seen. Maybe that's wrong, but that's just my personal feeling on the matter. So the next step to actually trying to decrease engineering costs is to come up with a more holistic solution. We've had years of experience of looking at how people use Onyx, where are the pain points, and we've identified the things that would actually, in fact, have a real impact on how quickly you could move an Onyx system from nothing into production. And primarily, we're finding that if you can tighten feedback loops in particular ways, you can increase someone's understanding and get them to move a lot faster. So we're looking forward to coming out with a technical preview in the next couple of months of what we've built. But I would say right now we're wielding the power of Clojure and ClojureScript to be able to let you understand what you're building at a significantly faster rate and in ways that other people really have not seen before. So I'm excited to be able to show that off pretty soon.
Sounds pretty exciting, and of course, fingers crossed, and we'll wait for the stuff. So right now, distributed masonry is 3 persons, right? Or if I get that right?
Yep, that's right. Immediately after we took the round, we hired Gardner Vickers, who's been a long-time contributor to Onyx.
Okay. So I have 2 questions. So how does somebody get into Onyx code base? So what are the interesting places where people can contribute to Onyx right now?
I would say the first place you could look would be the plugins, I would say, because it gives you a reasonable idea of, how the plugin, how the fault tolerance mechanisms work, and it gives you an opportunity to contribute something that's kind of self-contained and kind of grows the ecosystem a bit.
Yeah.
Yeah, I think in addition to that, looking at the Learn Onyx workshop and then using that as a springboard to investigate how Onyx core is actually working and kind of tinkering around with the various knobs would be a good start.
That's pretty nice. And my second question is, are you guys hiring?
Soon. I'd say we need a couple more months, but we are definitely looking to expand our development team later in the year and into next year much more.
Okay, so you heard here first. So distributed masonry will be looking for distributed computing programmers. So guys, get into Onyx and then build plugins. That's what my message for me, for our audience today. Okay, I think we covered a lot of ground today. Is there anything I missed? Right?
I guess I don't know. I don't know if this is a tricky area, but I'm interested in the kind of
in a job.
In a job. Yeah, come on, guys.
just say it.
You need to have proficiency in big F notation.
I've proven myself as a big F-er. Yeah. No, I was going to talk about some of the kind of emerging distributed computing thing that's going on, like lambdas and other things. I don't know if you guys are if you have a story or thoughts on the kind of process stuff or the serverless stuff. Maybe that's kind of outside of Onyx at the moment. I don't know. I'm just interested in that concept.
Yeah, I think that kind of comes along with the whole notion of doing a more holistic platform. We have some ambitions to remove the operational and the hosting requirements of Onyx and then shift that onto us, which is a pretty typical play for anyone doing a platform as a service. You're just going to move away all the networking drudgery that comes along with it. But we're really shooting for some middle ground where we're not. I think serverless is interesting, but it's a little too constrictive, in my opinion, for the amount of expressivity you can have. So I would say you'll start to see Onyx move in a direction from the hosting perspective where it's a little bit closer to that, but we'll still hopefully maintain the richness of the API that we'll be offering in kind of the same breath.
Okay. Because the reason I mention it is because some of the things that we're looking at in the stuff that we're doing is this kind of event-driven stuff where you can drive events through logs and streams and stuff like that. But for the slower moving things, then the serverless stuff is quite good for that.
I would agree.
Actually, I think serverless doesn't seem so good for. It's definitely not good for big data actually, but it seems pretty good for stuff where you don't want a kind of server up all the time. You only want it like an hour a day or something.
Right. I think that's really where its sweet spot is.
Sorry, Michael. I sort of stopped, but then I carried on. So, protocol problem. I'll let you finish.
No, Hangouts kind of burped on us. I was just saying I agree. I think that's really where its sweet spot is. It's a good use case for when you need really limited usage and you need it in an ad hoc way. That's what it was designed for, and using it for that is fantastic.
Okay, so horses for courses. I think we're right that what we're talking about generally with Onyx is dealing with large scale data sets and large scale problems, and like you say, a platform as a service would make things very nice.
Yep.
Okay, so can I ask one final bonus question? Okay, so Mike and Lucas, so you guys are doing a lot of research in distributed computing and spending a lot of brain cycles on it. Do you guys have any recommendation for reading? A paper or something like that? Anything would you recommend? A book, probably.
I would recommend reading the Morning Paper blog by Adam Collier.
Yeah,
that's Adrian Collier. Sorry.
Fantastic blog.
It's great. He explains things he summarizes and explains things in a really good, easy to understand manner, and I always pick up really interesting things there.
Yeah. Okay.
Okay, great. So I was just going to say, is there anything from your perspective, guys, that you want to add or talk about, or any upcoming things outside of the things we've talked about already that you want to mention?
Is there a secret fork of Onyx in Haskell?
No, we just no time for that. No, I think we covered the ground pretty well. That's those are the main points of Onyx. That was a good discussion.
Yeah, but I noticed, by the way, that I've talked to you a couple of times back and forth on the Slack channel, and that seems to be a very good place to go and ask you guys questions and get into the sort of swim of Onyx and the feel for things.
Yeah, the Clojarian Slack channel is best. Yep.
Excellent.
Okay, so I think that's it. We can round it up, I guess.
Yeah, fantastic. Thank you very much, guys.
Yeah, thanks a lot, Lucas and Mike, joining all the way from all sorts of weird time zones today.
It's a very distributed in every sense.
We learned a lot of things, and especially for me, it's been a fantastic discussion. And by the way, thanks to you, I was able to learn a bit of ASCII doc now. So that was useful for me.
Oh yeah, thanks for that.
And
we really appreciated that. Our docs needed the work.
I finally figured out those weird syntax in ASCII doc now. So that was fun. But otherwise, for people who want to get into Onyx, I could not recommend more the Learn Onyx thingy. And obviously, I'll try to do the workshop in Amsterdam Clojure meetup, and I'll poke you guys for questions. And I know that you guys are on Gitter and Clojure and Slack, and there is also a mailing list, as far as I remember.
Yep, that's right.
Yeah. So those are the ways you guys can get in touch with Onyx Brains, and. So that's it from us today, I think. We will post the notes on Def and Audio. And obviously the MP3 will be available on SoundCloud and iTunes and all other popular channels.
If you can leave a review, that would be very good. And Rich, if you're listening, tweet again. That would be also very good. So keep it going. One fan. Go on. Sorry, Vijay.
Sure, go on.
I was just going to say, are we done? Because I just want to say final credits. Thanks to. Okay, so just a final credit to Pizzeri, who does the intro and outro music. If you can give a bit of love to his SoundCloud, that would be good. The track is Melon Hamburger, and it's a vegetarian intro outro music. So that's great. Okay. Right, thanks a lot, Vijay. Great stuff, and we'll be back to Village Idiocy next time. And we'll be minus the big brains of Michael and Lucas. So thanks a lot, Michael. Thanks, Lucas.
Thanks for having us, guys.
Thanks.
It's been fun.
Thank you.
Okay. Bye.
All right.
Bye-bye.
Bye.